कनेक्शन का प्रॉब्लम हो गया था, एग्जिट हो गया था। ओके। Okay, we are into the last phase of our first chapter. Okay, so when we compare different types of vehicles, so here I have shown you the EV types. So BEV, HEV, and CEV. So fuel cell electric vehicle, hybrid vehicle, and battery electric vehicle. So driving component, we know that electric motor is there, and here we use electric motor as well as internal combustion engine and electric motor. So energy source, these are the energy source we use in the battery electric vehicle. Battery and ultra capacitor we use over here. Battery, ultra capacitor, and IC engine we use, and in FCV fuel cell we use. Features, these are the features: no emission, no dependent on oil. Range depend on largely the type of battery used and available commercially. This is HEV. Very little emission as compared to the internal combustion engine, totally gasoline engine. So long range will be provided by hybrid engine and can get power from both electric supply as well as fuel. So over here, complex structure because of both uh, sources of energy powers are there. One is from battery, another is from a IC engine. So electrical and mechanical drivetrain, both the drivetrain because of the complex structure is there over here. So available commercial, this is also. So very little or no commission features, high efficiency as compared to others, not dependent on supply of electricity, high price because of that reason it is not in the market. Okay, FCV is very higher price, available commercially. So which are the problems when we see BEV, HEV, and FSCV? So battery price is very higher and capacity is also very less when we see the batteries. Okay, range problems, charging time. So it takes two time to charge. Availability of charging stations. We don't have any charging stations, and it is higher in price as compared to gasoline engine or hybrid electric engine. It is very higher in price. Okay, so these are the problems when we see a battery electric vehicle. So HEV, so management of energy sources with the help of two energy sources. How you are going to characterize the energy? Just characterization we are going to see in the next slide. Okay, and detailed characterization can be studied in the hybrid electrical vehicle chapter. So battery and engine size optimization over here, very little, very small engine size is used as well as battery size is also is much. Matlab, we are going to optimize the battery as well as engine size. There is no problem of charging over here because over here also we use the battery because alternative power we are using over here. There is no way of charging. Okay, in the hybrid electric, the battery charge itself, मतलब charge करने का जरूरत नहीं है hybrid electric vehicle में. So that's why it manages the energy sources, both the energy sources. Last week I have shown you how it exactly, in this figure I have shown you HEV configurations, energy source 1 and energy source 2. So how exactly it manages the energy sources from powertrain 1 and powertrain 2. Okay, so fuel cell, that is cost of fuel is very higher, feasible way to produce the fuel, availability of fueling facilities. So there are, when we compare different, these are the some of the driving component, energy sources, features, problems are there. So when coming to the power flow in HEVs or power characterization in HEVs, so how we are going to characterize the power? So why we are characterizing a power over here or power flow in HEV? What are the power flow? So there are different configurations are there in HEV. Okay, there are different configurations. So these different power control strategies are necessary to regulate the power flow in different components as in the hybrid electric vehicle. Okay, especially I'm focusing on hybrid electric vehicle because so we are studying HEVs. So all the control strategy, okay, which are what we have to satisfy. So we have to satisfy the maximum fuel efficiency, okay, in HEV and minimum emissions. So there are many things are going regarding the emission standards. Okay, so as we have seen little bit in the beginning of this chapter, and minimum system cost. Okay, so as you see, if you go with an electric vehicle, so there is a high amount of cost is there. So normal people cannot bear that cost. Minimum system cost and good driving performance. So as we have seen the driving performance of a normal vehicle, that is a commercial vehicle, conventional vehicle, we have seen very what are the driving performance. We are going to increase the performance of the vehicle. So that has to be increased in the HEVs also. Okay, there are many ways to increase the performance. Okay, there are many parameters are there. Okay, so the design of power in HEVs involve different consideration. Which are the considerations we have going to take? So first is the optimal internal combustion engine operating point, and second one is the optimal IC operating line, and third one is a safe battery voltage. Okay, safe battery voltage should be there. So when we come to the optimal IC operating point, this optional operating point on the torque speed plane of the IC can be based on the maximization of fuel efficiency. Okay, and which will minimize the emissions or fuel, minimize the fuel use and emissions. So these has to be reduced. Okay, maximization of fuel economy. We have to maximize the fuel economy, as well as we have to minimize the emission, as well as we have to minimize the consumption of fuel. So whenever we use the ICE as a operating point, that is the three main things are there we need to take care of. So second is a optimal IC operating line. Okay, so what is that? So in the case of ICE, it needs to to deliver different power demands. Okay, so अगर आप हाइब्रिड इलेक्ट्रिक व्हीकल कंसिडर करोगे तो सिंगल कॉन्फ़िगरेशन पावर फ्लो से नहीं चलेगा. So to improve the performance of the vehicle, you need to deliver different power flows in the hybrid electric vehicle. So here we are considering optimal IC operating line. So in that case, there are a different configuration we need to provide according to the demand or delivery of different power. Okay, so the corresponding optimal operating points will constitute an optimal operating line. So safety of battery voltage. What is the safe battery voltage over here? The battery voltage may be significantly altered during charging, discharging, okay, and generative charging or regenerative braking. This battery voltage should not exceed the maximum voltage limit, and or should it fall below the minimum voltage limit. So we have to take care of a safe battery voltage because it is very riskier to use in the vehicle, so that anytime anything happens, so that each and everything we have to take into consideration for safety of a battery voltage. Okay, अगर higher voltage हो जाएगा तो कुछ अंदर का cells वगैरह जल जाएगा. So it creates a problem to the harness of the vehicle. Okay, if it is higher voltage or when it goes to the lower voltage also, whenever we have to take care of. So battery discharging, how? the battery is discharging. So that's why it is very important. The battery management system is very important in the case of when we consider a battery. Okay, also during the generator charging or regenerative charging. So in that case also it is very important to take care the battery voltage. Okay, so these are the some of the power flow characterization. Power flow in HEVs. How we are going to uh, characterize power flow? These things are studied in detail in the hybrid electrical vehicle chapter, drivetrain chapter. So in that we have a uh, one point is there like power in hybrid electric vehicle or flow in hybrid electric vehicle. In that, so we are going to see the different modes of power flow in the hybrid electric vehicle. Just we are going to see the characterization over here. So how we are going to characterize the power flow in HEV? So power flow control in series hybrid. So when we see a power flow control in a series hybrid, so there are four modes of power flow control in a series hybrid we have. So first is for normal driving or acceleration. So when we consider an series hybrid vehicle, so with the help of a figure we are going to study in the future chapter. So second mode is for the light load. Okay, how the power flow we should power should power flow should be there for a light load. And mode 3, so what will be the mode 3? So for mode 3, the braking or deceleration. Okay, the braking or deceleration is there for a mode 3. And for mode 4, okay, so vehicle at a stop. Okay, so when the vehicle at a stop, how the power flows in a HEVs. So when we consider into the series hybrid vehicle, so mode 1, what is mode 1, what is mode 2, what is mode 3, what is mode 4? So these, how the power flows exactly whenever we are accelerating the vehicle, we are decelerating the vehicle. So whenever we brake the vehicle or whenever we stop the vehicle, in that case, so we are going to consider over here the link. Which are the link we are going to consider? So one is the electrical link we are going to consider. Second is a hydraulic link we are going to consider. Third is a mechanical link we are going to consider. So what are the parameters? What are the components we are going to include over here? So battery, then internal combustion engine, how the power will be flown, then generator, motor, and power converter, as well as fuel tank. Okay, so source of power storage is like with the help of fuel the power will be generated, as well as for the for power for the you we use a generator in the case of motor, and that will be converted, the power converter. Okay, whatever the required amount of power is required to the motor, so that will be converted with the help of power converter. So and which are the transmissions? Also transmission thing we are also considering over here. So that includes brake, clutches, and gear, which with the help of figure we are going to study in the hybrid electric drivetrain chapter. Okay, so power flow control, this is some of the modes are there in the series hybrid. Okay, when we see into the parallel hybrid, again we are going to see this mode. Parallel hybrid में total there are 6 modes are there in the parallel hybrid. Okay, so first mode is for startup. Okay, in this parallel hybrid, first mode is there for startup. So what is how the power will be flown whenever we start the vehicle. And the second mode is there for acceleration. Okay, third mode is there for normal drive. Okay, fourth mode is there for braking or acceleration. Fifth mode is for battery charging during driving. Mode 6 is there for battery charging during whenever the vehicle stand over there itself. मैंने मतलब stop करके हम लोग एक जगह खड़े करते हैं ना. So in that case, how the power will be flown whenever it stand at a particular location. So these are the six modes are there whenever uh, six modes are there for a power flow control in a parallel hybrid. So series hybrid में चार मोड है, parallel hybrid में six mode है. So for each and every mode, how the power will be flown, okay, inside the drivetrain. Okay, so as you consider internal combustion engine, or as you consider the motor, so how the power will be different at a different modes. Okay, so just only characterization, the power flow characterization I am explaining over here. Okay, so flow control in flow power flow control in series parallel hybrid. Okay, series parallel hybrid दोनों में भी हम लोग स्टडी करेंगे सीरीज पैरेलल हाइब्रिड में क्या रहेगा. ठीक है, so there are also some modes are there. What are those modes I am going to tell you. Okay, so again the power flow control in a complex hybrid. Okay, so in the hybrid control, so complex में भी हम लोग स्टडी करेंगे. व्हाट आर द पावर फ्लो कंट्रोल्स इन अ कॉम्प्लेक्स हाइब्रिड. देयर आर टू टाइप्स we are going to study in the future chapters. So flow control in a complex hybrid control. So first complex hybrid control is a front hybrid rear electric. So front और hybrid रहेगा, rear वाला electric रहेगा. Okay, and front electric rear hybrid, ये दो different टाइप्स वी आर गोइंग टू स्टडी. एक हाइब्रिड फ्रंट रहेगा, रियर इलेक्ट्रिक रहेगा, रियर फ्रंट इलेक्ट्रिक रहेगा, रियर हाइब्रिड रहेगा. तो कैसा वर्क करता है. सो यहाँ पे दोनों जो है, both the configuration have a six modes of operations. So mode 1, mode 2, mode 3, mode 4, mode 5 and mode 6. So mode 1 is for startup, and mode 2 is for full throttle acceleration. Mode 3 is for vehicle which is in when it is running, uh, and as well as battery when it is running, how the battery is charging. And mode 4 is for the light load. So when the load is very light, so how the power flow control in a complex hybrid. As well as mode 5 is braking or deceleration, and mode 6 for balancing. So whenever the vehicle is balancing, how the power will be controlled in a hybrid electric vehicle. Okay, so that is for a front hybrid rear electric, as well as front electric and rear hybrid. So over here also we use like battery, front motor, front power converter, front axle, as well as, so in the case of front hybrid and rear electric, I'm telling you. So and rear motor and rear converter, so electric will be is there in the rear uh, position. So rear power converter, rear axle transmission. So there are three links we are using over here. With the help of links, we are going to identify so how exactly the power flowing in the complex hybrid control. Okay, so electrical link, as said, electrical link, hydraulic link, as well as mechanical link, we are going to use over here. Okay, so these are the different power flow in achieve characterization of different power flow in HEVs. So detailed study will be done in the future chapter with the help of figure. So just coming to the one video, so just rewind of this chapter. So this conclude the first chapter over here. So first chapter completed. So just I'm rewinding the first chapter over. Just see the video. Okay, yes, this is a rewind of hybrid electric vehicle. In short, I have shown you one with the help of one video. So one more video I'm going to show you. So it is regarding the performance. Okay, these are the just two video I have shown you for the remind purpose. The first video is for hybrid electric vehicle. Second video is for just the performance of vehicle. Like if you see dynamic performance, if you see there are crash tests are there and aerodynamic tests are there. Okay, there are different types of performance are there in the vehicle. So how exactly the performance is increased of vehicle we have seen. So the first chapter is concluded over here. If you have any uh, questions, you can ask me. So for the first chapter, you are going to uh, refer a book. Already it has been the PDF file has been uh, sent to your WhatsApp group. Already sir has been sent. Kale sir has been sent. Just that book you need to refer, or else I'm going to send you the notes for the first chapter. Okay, the first chapter के notes पे I'm going to upload on a VOLP. So today or tomorrow I'm going to create a VOLP, VOLP classroom. So just you join that classroom. I'm going to upload the notes in that particular classroom. Okay. If you don't have a questions, okay, what we will go? We will go with the evaluation test. Okay. Evaluation test of first chapter. So are you ready for the evaluation? I have created some 10 questions. Okay. Just you need to solve those 10 questions. Okay. And that is not considered for the first CIE. Okay, first CIE will be conducted later on. So just for the evaluation purpose, I have put that some 10 questions I have prepared for the first chapter. So you need to solve that. So I'm going to send you the link now in the chat box. Just you go through all these questions and you solve. Okay, I have put a Google form in the chat box. Okay, so just you solve this and submit it by 15-20 minutes. Okay, so I'm going to start the second chapter tomorrow. Okay, second chapter in the same time for morning 8 o'clock. Okay, you can put your attendance and you can attempt this test by up to 9 o'clock. Okay, at 9 you have to submit your this evaluation test. Okay, just put your attendance in the chat box and solve this test.